Hello my friends and welcome. My name is Dennis and as you probably know I'm airline captain, and recently I heard the news that Airbus company introduced several of the airplane concepts that will use the alternate fuel. So today we are going to discuss with you whether the jet fuel era comes to the end. This video is promising to be very interesting. Stay tuned. And here we are at the Airbus official website. You may see different airplane concepts. First we see the turboprop airplane, seems to be like turboprop, looks similar to ATR. Actually I used to fly the ATR 72-600, wonderful airplane, and it's very similar to it. The nose is a little bit different, it goes a little bit down over here and looks similar to this jet airplane. Also we have the flying wing concept, and it's Airbus Maverick concept. They are working on this project, and from what I see, from what I can say, that this project may have future. It has some disadvantages, I'll tell you about it later. And also I had the video before about the flying V that KLM designed together with TU Delft University. I think flying V is not a good idea, but this flying wing is pretty much okay. This Maverick will fly probably. Also we have the jet airplane. I think it's the class of Airbus 320 or 321. Very linear, little lines are very smooth, and you can see zero emissions, zero emissions, zero emissions. Now we can see this only on electric cars nowadays, but here we have H2 energy. I see H2 energy means hydrogen energy, so they will burn the hydrogen, from what I can see, towards the world's first zero emission commercial aircraft. Well, it's okay. They have the ambitious plan to launch this project by 2035. Hydrogen propulsion will help us to deliver on this ambition. Our zero concept aircraft enable us to explore a variety of configurations. So we have turbofan, turboprop, blended wing body airplane. Probably this won't fly, it's still in the concept, maybe it will fly. The problem I see here are those engines. On high angle of attack, they may be shadowed by the wing body itself, so we'll have some kind of engine stall, engine storage stall, so we need to fix the problem. On B-2 Spirit, the bomber, the American design bomber, they fixed this problem by installing the extra hatches on the top of the air inlets that will help to direct the airflow into the engines. Here the intake is far behind, so they need to change probably air intake for the front part somewhere here, to make the holes over here to let the air goes without any obstructions. So here we have the video, let's watch it. Airbus introduces zero emission airplanes. First, turbofan. So it's 200 passengers, 2000 nautical miles of range. Okay, let it be. It's very similar to what we have now. At least for the passengers. Cruise speed Mach 0.78, it's alright. The maximum Mach for Airbus 320 is 0.82 as far as I remember, and it's pretty close to what we have here, what we have now in commercial aviation, and it looks interesting. I don't know why they use this kind of thing. Maybe it's the VHF antenna or something. I really like the design, the wing, it's streamlined. Well, I really like this type of the airplane. The next we have turboprop. Well, the computer models are great. It's nice turboprop airplane, my friends. It's very similar to ATR, very similar. The evacuation hatch in the same place as on ATR. Maybe on ATR it's in the central part. Here we have more close to the first officer, but it's very similar to ATR. I would like to try to fly this turboprop, and also the wing is different. As you can see, we have different areas. So now here it's more narrow compared to the central part of the wing, and for the stabilizer and elevator is the same. Probably have auxiliary power unit. The ATR doesn't have this feature, the auxiliary power unit. And yes, the blended wing body. Well, the deputy vice president of Boeing said that the blended wing body designs will not be introduced in commercial aviation in the nearby future, but Airbus designed this model. From what I see here, my friends, you still have some kind of fuselage, you still have some of the wings. So yes, it's a blended wing body, but it can take lots of payload inside, and if you have the turbulence problem, for example, on flying V concept, here we don't have this problem because wings will just wave in the turbulent conditions, and your, let's say, fuselage part will stand still, like a modern type of airplanes that we have right now. Very interesting concept. Probably they will have no problems with air intake. From what I see here, maybe it will be enough to direct the airflow into the engines. Again, 2000 nautical miles, 200 passengers, the same that we have for this jet airplane. And by the way, what's about the turboprop? 1000 nautical miles and 100 passengers. It's more than on Dash Q400, more comparable to ATR. ATR 72600 can take 70 passengers as maximum. Mach 0.5, it's okay, it's the same speed as we have on ATR. Yeah, wonderful concepts, my friends. Wonderful, absolutely fantastic machines. Yeah, what I'm concerned about the air intake here. So it should be limited. I mean, the pitch should be limited. Maybe the angle of attack should be limited, just not to cause those engines to get the flame out. Because of the high angle of attack, then the airflow will not go inside the engines. So they all promise to be powered by hydrogen H2. Estimated entry into service by 2035. Well, we'll still have the problems with that by 2035 because you don't have the infrastructure for hydrogen fuel so far. It's still concept, so I think there will be maybe in service a couple of those aircraft, but the logistic of delivering this H2 fuel everywhere will still be low by this time. 0E. Nice concepts. Alright, one more video on their website, and here they're just talking about those concepts, and yeah, zero emission style. Some wear masks, some of the guys do not wear masks, like in real life, you know. And it's not about this video, my friends. My video is not about this video. You may check this talkative video on their official website. I'll put the link for Airbus website, and together with you we are going to talk about the fuel. It will be a little bit of chemistry. I'm not good at chemistry, but let's start and let's discuss the different types of the fuel, the fuels of the future. Pam pam. Alright, first, why do we need the fuel? We need to burn it to convert the chemical energy of fuel burn into the mechanical energy. Well, first we let the air inside the engine, air inlet, then we compress the air, then we heat the air up using the chemical energy of fuel burn. Basically, it's oxidation of the jet fuel. Then this heated air transfers the energy into the turbine, transfers it to kinetic energy. The turbine itself rotates the fan and the compressor to compress the air, and then we have the exhaust. The air just exhausted through the exhaust cone. So that is why we need the jet fuel. The same principle is applied to every internal combustion engine, for example, piston engine. And let's discuss with you the jet fuel that is widely used around the world, the Jet A1. It's like this, Jet A-1. It's commonly used in most of the airports. What we have here is the molecular structure of kerosene of the jet fuel. It's look like this. We have carbon and we have hydrogen. It's the typical molecule for every fuel, every type of fuel, except of hydrogen fuel. I'll discuss with you it a little bit later. So for jet fuel we have around 8 to 16 atoms for this molecule, atoms of carbon. It means that this molecule is very long. Just imagine carbon, 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 like 8 times or even more. That makes this molecule very, very long. And let me show you more detailed picture with our standard benzene or automobile fuel. The automobile fuel, the benzene formula will look like this: C5H12. It means that we have 5 atoms of carbon and 12 atoms of hydrogen. The less carbon you'll have in your fuel, the better it is for environment, and the less toxic parts you will have after the fuel burn. So it will be the best fuel for your automobile. So if you have C5, it's the least that you may have for benzene, for petrol. So we have 5 molecules, 1, 2, 3, 4, 5, and they all surrounded by hydrogen. It's not the hydrogen fuel, it's our usual fossil fuel, my friends. H. So we have around 12, not around, but 12 hydrogens. So we need to burn this fuel. The burn needs to oxidate this fuel. We need to put the oxygen inside. Oxygen that will perform the reaction. So we burn it, we'll heat it up, we'll pressure it inside the combustion chamber, inside the compressor for better combustion. And oxygen will separate this link, separate it here, it will separate it here. And because of this carbon and because of the lots of oxygen around, so the oxidate reaction will go on, we'll have some of the separation inside the molecule. Because of that separation, the energy released, so the heat energy heats up the air, and then this air performs the mechanical work. So that is how we convert the chemical energy into kinetic energy that performs the job, the work. Because of the chemical reaction, we'll have new elements. Because of this oxygen, it oxidates and we'll have new elements. Because we have the nitrogen in our air, we also have nitrogen reaction. That is why we have the toxic elements out of this standard fuel, the jet fuel, the car fuel, benzene. So we have CO, we have what else? We have CO2, CH. Because of the nitrogen we have NO2, NO3. So they all toxic elements. That elements may be avoided by reducing the carbons inside your fuel. So this is the minimum for the jet fuel, for benzene, is to have 5 atoms of carbon. Well, for jet fuel I think it's around 8. So for jet fuel it's 8. For petrol that you use in your car, the best will have 5. So I think you got the point. Can you use propane to fly the jet airplane? Yeah, why not? I saw some of the engines, the jet engines, operate on propane that you use for your cooking. So the propane formula is we have less carbon. So we have C, totally 3 atoms of carbon. These guys have 3 hydrogen atoms. In the middle, this guy has 2, and those have 3 atoms of hydrogen. So you see, less hydrogen we have here. So totally we have C3H8. And together with oxygen, it will give us the CO2, of course. carbon emissions plus H2O. So it's more efficient, more ecological fuel, and the less carbon you have, the more energy you need to oxidate this fuel. So the more pressure you need to realize inside the engine, the more pressure ratio, I would say. If we are talking about, for example, piston engines, you need to rise up the pressure inside the engine to combust this type of fuel. If you have many of the carbons, like in jet fuel, you don't need a lot of pressure inside to combust the fuel, because the chain is very long and it's very easy to cut it with oxygen. Here it's not so easy to cut. And let's speak about the biofuel. There are two main types of biofuel. First is ethanol and the second is methanol. The ethanol is widely used everywhere, in a pharmacy, in making the alcohol drinks, and methanol not widely used because it's very toxic. The ethanol has structure of just 2 carbon atoms, and it has 1, 2, 3, 4, 5 atoms of hydrogen, and also radical OH. OH means the radical that connects to the ethanol, and it helps to burn this fuel, actually, because it has extra oxygen, and the reaction of oxidation comes very, I would say, very fast. However, the heat that we have from the ethanol is less compared to the standard benzene or jet fuel. So we need more of the ethanol to burn to have the same amount of heat. But you can compress this fuel and you can have more, let's say, power from it. And it's very ecological because you have just very efficient and very environmental friendly, because you have just 2 carbons. But for methanol we have just 1 carbon, and 3 atoms, let's say here, 3 atoms of hydrogen and also radical OH. So I think it's more efficient. The most efficient biofuel is methanol, but the bad thing is that it's very toxic. You can have poisoning even from the vapors of this methanol. So it's not widely used everywhere. Ethanol, it's okay, it is used. Some people just drink it, but it may be used as a biofuel. The problem with biofuel is you need to grow some weeds, need to grow some agriculture, and that fields, I would say, that land may be used to produce not the fuel but the food for the people. So I think it's the main reason why we will not see this type of fuel widely used in commercial aviation, because it's better to grow up some food to feed the people, hungry people, not hungry people, everyone, rather than that make the ethanol and methanol from this type of fuels. But methanol, of course, it will not be used for commercial aviation because it's very toxic, my friends. And let's go to hydrogen fuel. The hydrogen fuel is not as simple as you think. Well, we have the simplest element, hydrogen. Usually you may find it as H2 element, and you can say that if we react with oxygen, you have some of the fuel, you have some of the process where you have the burn fuel and you have the energy. But no, they will not react. What are the elements that may react are the free radicals like OH, O or H, and that makes that reaction very complicated. Let me just draw you. For example, we release the radical OH. OH will just draw here, and it will react with the hydrogen because it's searching for negative electron, and hydrogen has 2 negative electrons, H. So, and this will give us the water, H2O, and it will give us the free radical of hydrogen. As simple as that. And this free radical of hydrogen then will react with the other element. The other element is oxygen. So if we react with oxygen we'll have two radicals released, OH and what is left, O. So we have two oxygens, and now we have two atoms of oxygen and one of hydrogen. And then oxygen again reacts with the hydrogen over here, H2, and that's the chain reaction, my friends. You may say here we have the water, but no, again we have two free radicals. That's how chemistry works. We have OH again and H. Very interesting. The water we can get only from this reaction, from OH with H2. So here we have H2. So if we add again plus H2, we'll have the water H2O, and we'll have the free radical H. And the chain reaction continues. So here is the same reaction as we have here. So we managed to circle the reaction. So that's the basic reaction of hydrogen, how the fuel burns. And at every type, then the new molecule appears, there is the heat, the energy comes from it. So we have explosive reaction, not compared to usual fuel, the carbon emission, that fossil fuel with carbon emissions. Here we have explosive reaction, and that's the main problem of hydrogen fuel. Hydrogen and oxygen may be together for a very long time, but if you put a little bit of fire, if you free this radical, you will have this chain reaction and everything will explode. So the main thing for hydrogen fuel is to control this explosion. From what I see, my friends, is you need to have H2, hydrogen, and O2 in different compartments, let's say this compartment and that compartment, and partially put it into some kind of combustion chamber. That will be the combustion chamber, that you have the reaction. You may put some warm temperature to release the radical, and here you have dosed reaction that may perform the job, that will transfer the chemical reaction into kinetic energy. So it's need to partially put hydrogen and oxygen. That's the main thing why we don't have the hydrogen engines, powered engines, so far only installed on the concepts. But I think, my friends, that is the future of commercial aviation. All of the jet engines will be transferred using the hydrogen fuel in future, of course, because the hydrogen fuel has enough energy for the spools, for the jet spools to rotate. It will guarantee enough power for the jet engine to operate, because for electrical power, well, we have quite heavy batteries, we don't have a lot of power to rotate the spools, so that is why it's the future, and also it is environmental friendly fuel. The one emission you may only have is water, so the other parts and the other atoms are always in reaction with other parts. So it's very safe fuel in one way, but very unsafe fuel because the reaction is uncontrollable. So the main solution now is to create some kind of the engine or fuel supply to deliver the fuel in the most safe way, to provide the good standards for commercial use. I know you are watching my videos very often, that is why you are awesome guy, and you need to follow the special awesome guy checklist. First, you need to like this video, then subscribe to my channel, then ring the bell, whatever it means. Thank you very much for watching this video, and have a great time!
Pam pam.